couple times last week where I was like, third period's got me scared about this upcoming quiz. And don't get me wrong, there's a couple people where your focus throughout the week was poor, and so your result on the quiz was also poor. But there were some people that they decided last week, this is when I'm going to turn it around. Or maybe midweek, they did turn it around. And so the first half, a little shaky, second half, really strong. And so on that quiz on Friday, you guys did really, really well. So give yourself a round of applause. We're not done yet, so Coriana just kindly reminded me we need to do our Monday circle. So circle up you have to see that person before you say their name. And if they're absent, tap their name. I need you on the circle in 3, 2, 1, 0. Okay. So remember, the purpose of the circle is to set some goals. Michael, do you mind scooting in so that I can, you don't feel like you're on the outside of the circle? You're not on the outside. Set some goals. So I told you the past couple weeks that we would be pretty classwork heavy, and we've been feeling that. But it's all for this investment for what we get to do now and what we get to do next week, what we get to do leading into fall break and coming out after fall break. So I'm going to tell you both of those things. This week you're going to design your own lab about energy. And we're going to talk about your objective for today. You're going to develop an experiment to test potential and kinetic energy transfer. That sounds really simple, but it gets pretty complex when you get into, hey, you know what? Mr. Carl's not telling me how to do this time. Focus, please. So I need everyone to be on that attention like you had Thursday and Friday of last week. I need that Quincy decided he's not going to end up doing poorly on another quiz last week. Because Quincy, by the way, I can't remember, but I think you got like a 96 or something. Pretty good job. I need that energy from everybody. I want you to think about, do you want to be a student that all the way through 12th grade, you get told what to do every minute of every period? No, of course you don't. What we're doing this week is you get to decide that for yourself. You're going to design your own experiment. There's some requirements. There's some things that you have to check. And you're all going to end up coming to sort of similar experiments, but it is still your own design. And after we get to do our experiment, then we're going to go into where you end up presenting this information that you found on your own. It's a very, very cool feeling. It's also about something that you're going to be familiar with, potential and kinetic energy. So that's what we're doing this week. I need that refocus, end of the quarter, I want my grade to look as best as it can for that report card, energy, all week long. Then next week, we will start our project for the energy unit. The last thing that we do before we move on to the next unit. Okay, which one? Super interact. See you right here.
Yeah.
All right, great. Next week, we're going to be building Rube Goldberg machines. Now, you might not know what a Rube Goldberg machine is, but a lot of people have seen them. If you get on YouTube, you've seen a video where it does a very simple thing at the end, but it goes through all these complicated steps where a ball rolls here and it hits the dominoes and those, and then it launches something and then that lands in a bucket, which then goes, you know what I'm saying? You've seen those, and then it's all just to flip a light switch on. So you guys are going to build your own Rube Goldberg machines, and we'll go into more details of that when we get to next week. My point in telling you that is it's all building, doing hands-on stuff now because you've invested your time in the classwork from last week. But I'll also give you a warning. Don't waste that investment by goofing off whenever you're given time to structure your own group. Okay? Who has a good goal for what they want to get done this week? Coriana? Tyshawn?
Persevere.
Huh?
Sound hard.
You what?
Persevere. Sound hard.
I'm going to persevere. That sounds hard. Okay? Persevere when it's confusing,
Yeah.
when Mr. Carl doesn't tell us everything to do. I'm going to persevere. Tyshawn?
I want to talk less in the class.
All right. I think everyone in the class would appreciate that from you. And arms out of the shirt, please. But I appreciate it. You said it. Who else? Someone from this side of the room. Not Mr. Clark. Thank you, Shania.
I want to get all my work done.
Girl, you will get all your work done. Be in charge of your table, not getting off task. This is going to be the most important week ever for this poster. It's going to be really tempting to say, whew, he's telling us we got some 15 minutes. Let's hang out for a little bit. Don't do that. Don't fall into that trap. Head back to you. Good circle! Gentlemen, in your seats, please. All right. This week we have a very simple question to answer. How can you, or I'm going to say I a lot, how can you make an action figure jump higher? What kind of ideas do you have? Dwayne. Throw them against the ground so they bounce? Like that? Okay? Tyshawn.
I would have to say, you should kind of make up some kind of system to where it jumps right.
Keep going. Keep going. Make some sort of system that makes it jump higher. So what would a system like that look like?
Probably like ramps and screens. Like a bully.
Like a seesaw? Okay. A rubber band? What kind of energy does a rubber band have? Woo! Okay, Coriana, last one.
You can have a like that makes them pop up when it's touching something.
Okay, so some sort of like trigger, where it's on a spring or something. Quincy, you just throw it in the air. Action figures can't jump, they're fake, right? All right. So we're gonna investigate this question. You'll never, ever, ever feel like you've looked into a simple question closer than what you're gonna do this week. When you walked in, you picked up a packet that has this, that has this on the front. This is your reading log. I want you to tear that sheet off, please. Boom. Sarah did it already. Little pro tip. Did you know, and you can't test this more than once, but if you have a packet of papers and the teacher says tear 2 sheets off or whatever, wherever you tear your packet, this is a teacher tip too, wherever you tear your packet, whichever side has more papers in your hand, let's say it's 3 on this side, 2 on this side, you tear it apart, the staple's going to stay with it, whichever side has more. So as long as you're only holding 1 sheet and then the other 3 are over here, and you just, the 1 will separate from the staple. So now you have your your note catcher torn off, and then you should see this at the front. What do we see right here? You said it, a seesaw, a teeter-totter, or as they call it in this article, a teeter board. Yeah, good question. This is what gymnasts use when they want to jump higher. So we're starting to develop this idea about how can we make an action figure jump higher. Gymnasts use teeter boards, where one guy goes, and then obviously if I do that, being my size compared to Jayceon's going to fly over to the next neighborhood, right? Okay? So what I want you to do is take 15 minutes to read the introduction, the task, on the other side. So flip it open, please. Shuffle, 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 shuffle. Papers, 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 papers. Flip it open. You're going to read all of these supplies and safety precautions, all of that. You're going to get all the way to page 3, and you're going to stop. Everyone flip it over to page 3. You're going to stop where it said, don't put that back in then if you've already torn it apart.
No, it's not. It didn't have a paper.
Okay, then put it in the trash. You're good. I want everyone to circle where it says initial argument on page 3 and write the word stop off to the side. Alicia, initial argument on page 3, circle it, and then write the word stop off to the side. Stop. That's where we're stopping with these 15 minutes. So in 15 minutes, you're reading 2.5 pages. Do you have time to mess around?
No.
No, but you will have fun reading about it. And I think you'll also have fun realizing how much you know. What I'm looking for as I walk around is I want to see you marking up the document for major ideas about potential and kinetic energy. I want to see you marking up the document for ideas that directly relate to the question, how can I make an action figure jump higher? And then after you've marked up the article, those are the exact things that you put into the no's, questions, and goal sheet. Okay? Any questions? Yes. Oh, Quincy asked a great question. Are we doing this as a group? Absolutely. You have 15 minutes to read as a group. 15 minutes as a group. No, because one thing you do is really good. They get the arrow and everyone knows. Are you okay? So that's going to make it hard. Terry's reading for his group. Good job. It all takes one person to decide. I'm not going to waste time. No, hang on. As you guys just having a conversation, better than that. All of you guys. I think way higher. Wait, pause. Like at least say, hey, Mark, you hang on a second. Don't start conversations while someone in your group. People usually be respectful. I think I can handle it. You know what I'm saying? I can handle it. Who's gonna be around? Who's gonna be in classes with the longest? You got 7 years. Find out where the easy is on the front, and then you start reading from there. Hey, got it. Got it. Check your time. Have you underlined anything yet? Have you written anything in the no box yet, or the question box? So what I'm looking for, annotation just means underline and then maybe write a note here. I'm looking for underlining major ideas of potential and kinetic energy. And then anything you feel like this directly relates to how I can make an action. Take a moment at this thing. They get a moment to talk about what you think it should be. Leo's got three. We got some great co-leadership from Sarah and Morgan. So think about it. You talk about
For example, think about climbing a hill. If you're at the bottom of the hill, you're at the beginning, you move.
I know is it.
You are transferring.
Maybe thank you.
And you are you have greater central energy. Investigation to explore.
So check your time. Make sure you're feeling ready to go. You're nearly halfway. You're doing great. You also need to get to midway down on page 3. Kinetic energy is energy of motion. I mean like 2/10 of a pound. Alright, ladies and gentlemen, I'm going to pause the timer. Give me your attention up front. I think it's important that we just touch base really quickly. Has anyone gotten to the experiment, like what supplies you get? Okay, so we're building some sort of an experiment. What ideas from this front page are helpful in how to build the experiment? Quincy first.
What do they call acrobats?
Okay, tell me more.
The thing they doing right now that helps them.
Okay, so the things that they're doing right now, they're on what's called a teeter board. A teeter board are typical pieces of equipment found on the playgrounds. They're used in shows that focus on gymnastics tricks. Launching another performer high into the air, it's easy to observe how the activity of a teeter board involves objects in motion. So something about this teeter board helps us answer this question. Very good job, Quincy, underlying that. What else? What other ideas do we find in this first page? You're not done with your time, you're halfway done with your time. Go ahead, Terry. Potential energy can be stored, when energy is stored in one form or another, it's called potential energy. When energy is stored, it's called potential. Now, further down in that same paragraph, it gives us another way to refer to potential energy. One we haven't talked about before. Sequoia? Huh? Position, it's the energy of what? The potential energy is the energy of position. Good. So, indeed, potential energy can be referred to as the energy of position. What in the world does that mean? Quincy. I need everyone tracking Quincy, please.
That,
Thank you.
whether it's not potential depends on the position.
Okay, so let's talk about the word position. How do I change the position of this clay ball?
You move it.
I move it. Great. What directions can I move it?
Anyway,
Any direction. Up, down, left, right, back, forward. X, Y, and Z axis. So, if I move it up, it's a different position. So, if I move it up, does it have more or less?
More potential.
So, you see what they mean when they say potential energy is the energy of position. The position of the object. When we're talking about gravitational potential energy, higher equals more energy. Lower equals less energy. That energy is based off of its position. Say it, based off of its what?
Position.
Good. Kinetic energy, we've always called it the energy of motion. We're good to go there. Okay, great. We've got the concepts out of here. We've got how, in real life, some people use a teeter board to make a human figure jump higher. Some of you just need to make sure that you're getting your nose, questions, and goal written down on this sheet. You have 7.5 more minutes. Remember that you're going all the way through page 2. Make sure now you're looking at how am I designing this experiment. 7.5 minutes, go.